Okay, so we've learned a little bit about using math methods, and so we're going to apply that to this problem here, where we're trying to figure out the time in seconds it takes an electron to move between the cathode and anode of a cylindrical rectifier tube, and which is apparently governed by this equation, and I have no idea what that really even means, but we're going to go ahead and do what we can do here. So we see that there's a square root here, so we're going to have to use that math.sqrt. When you're doing z and z squared and z to the third and z to the fourth, you could just do like z times z here, but we'll go ahead and use that math.pow method just so that kind of get more familiar with that. Down here we're using scientific notation, so we can remember how to do that. And then right here we have a natural logarithm, which again, if you don't know what a natural logarithm is, don't worry too much about it. We're just going to go ahead and solve this problem here. So we're going to call the class electron velocity. Okay. So I'm going to make a new class. Call it electron velocity. I want that thing to have a main method. And then I'm going to finish. Okay, so that gives me this new class called electron velocity. And I just want to make this so that I can see that equation. Okay, and kind of similar to what we've done before. So M is something that I know, Q is something that I know, V is something that I have to input, R1 and R2 are things that I have to input, Z is something that I'm going to calculate. So since I need to input things, I'm going to go ahead and use a scanner. I'm just going to call that thing number reader. Alright. Then I'm going to start prompting for the things that I need for this problem. So I'm just going to put enter applied voltage in volts. And then that's going to be a double. So volts, or V, is going to equal number reader dot next double. Alright? And when I did that next double, it automatically imported scanner for me. We talked about that the other day. Okay? What does what mean? All the junk on here? Is that what you're talking about? Or what we just did here? So which one are you asking me about? Oh, this here, we're just prompting for some input, right? So we're asking the user to give us the volts that are applied to this situation. Okay? And to be perfectly honest with you, I don't really know what all this stuff means or is for. Okay? So you don't really need to know that in order to program it, right? It's just we know that we need to know the voltage. Okay? So we're just going to say, hey, enter the voltage. If you're using this program, you must know what this stuff means. Okay? And we're going to do the same thing for the radius of the inner tube in meters. Alright? So I'm just going to copy and paste this stuff. Right? And then change this a little bit. So enter the radius of the inner tube in meters. I think that's what it said. Yep. Cathode and anode. I've heard those words before, but I don't know what they mean. And that's going to be called R1, according to the little thing there. And then we're going to copy and paste that. And this is going to be the outer tube. And that's going to be R2. So all in all, we have 3 inputs: V, R1, and R2. Okay? So you got to get, you want to be pretty good at copying and pasting because it just makes your life go a lot easier here. Okay, so then one other thing that it tells me is that the mass of an electron is this number. Okay, so we're going to go ahead and make a variable. Okay, they called it M sub E, so I just call it ME here. Okay, that mass of an electron is 9.1083 times 10 to the negative 31. So it's not very heavy. Okay, so why don't you guys go ahead and try to create your own variable for QE. All right, and I'll do it up here while you're doing it, and you can kind of double check your work there. Okay, so hopefully you did something like what I did in line 19 here. Okay, QE equals 1.60206 e to the negative 19, or times 10 to the negative 19. Okay, and the units of that are C, which I don't know what that means. So charge, I don't know. Not much of a scientist right here, so bear with me. Okay, so the next thing that we have here is that we want to calculate what Z is now that we have been given R2 and R1. Okay, so I'm going to go ahead and go double Z equals, and then we're going to figure out how to find the natural log. So if you don't know what the natural log is, then I have to be sitting there thinking like, what are you talking about, natural log? Like we got to go into a forest? But it's actually a math thing here. And so it turns out that we have this method called log, which returns the natural logarithm of a double value. So that's exactly what I want. So I'm going to go ahead down here where I have double Z and put in math.log. And the thing I'm taking the log of is R2 divided by R1. Okay, so you guys don't need to have all these spaces in here, but I just do that so that it's a little bit easier for you guys to read from your seats. Okay, and then finally we're going to try to figure out this time equation. So time equals, and then we're going to go the square root of 2 times ME divided by QE times V. Alright, so there's a bunch of stuff to do there. So math.sqrt. Alright, and then the thing that we're doing here is we're going to go 2 times ME and then divide that by QE times V. Okay? So that's that first part of the equation that we have right there. Is that making sense for everybody? Okay, so you really don't need to do parentheses inside of here because it'll follow the order of operations regardless. All right. If you wanted to make sure of it, you could put parentheses around here. All right, but again, it's not really necessary. Kind of makes it a little bit longer there. Okay, so we're going to go ahead and then multiply that by R1 times Z. Okay, and then we're multiplying that. But remember that we can't just put parentheses. It's not going to figure that out. So we got to multiply that by parentheses. All right, and now we have this long list of stuff that we're doing here. So 1 plus Z divided by 3 plus z squared, okay, which honestly it's probably better to just do z times z divided by 10, okay, plus, right, z to the third. So I'll just do the POW method just so that we see some practice with it. Math.pow z3, so those are separated by commas, and that's being divided by 42. So now I'm here in the formula, okay? Then I got to add on z to the fourth. So math.pow again, z4, dividing that by 216. And thank goodness that is the end of our formula. Holy bejeebers. Okay, so it turns out that if you do stuff like this, you can, let's see if it'll let me go to the next line here. So I could separate that into two different lines like that. Okay, just so that you guys can all see it. The language doesn't really recognize that there's any space here. Okay, it's just going to clump it together as one big expression. So if you want that, you can. Okay, so then we want to print out something about the time. So system.print line. The electron took time seconds. Let's put that in quotes. Okay, so I'm just going to put that up there so we can run this thing. Alright, so just running this thing, the applied voltage, I have no idea. What's a good voltage here? 50 volts. Okay, enter the radius of the inner tube in meters. I'm going to think that these things are not all that big. So let's go with 0.5. That might be even too big there. I have no idea. The outer tube in meters, let's go ahead and say that that's 0.75. Okay. And then this thing is going to do all of this math that we just wrote down, all this calculation. You're going to see how fast it goes. Okay, so here we go. Done. All right. So it took close to 0 seconds for that electron to travel those 0.25 meters. Okay, so it does all that math and it does it really quickly. So it's kind of nice. That's what computers are kind of there for. So any questions about that? I picked out like one of the most complex ones that I could find. Okay, you guys are going to have some problems that are much easier than that. All right.